interested in coming up and doing question A? That's like from, from middle school, grade 9. Yeah, go ahead. Yes. You have to hit the pen button up top. Yep. And choose your color. Up to you. It won't choose one of those. No, you have to.
Green.
Okay.
Okay. 5.
Lovely. No, keep going. Keep going. I said lovely. I'm not being sarcastic.
This is 3. This is 1. 6. 1. 3. So 1. 3 times 3 is.
Thank you. Notice what she did. And those of you that were in my grade 9 math class, I desperately tried to get you to do it this way. And the reason why I got you to do it this way is because of what we're going to be doing today. Some students will do this, right? And it's not wrong. It's just, it doesn't work well for when we do these type of questions. So some students, when they see this, they'll multiply first. So they'll remember, oh yeah, you multiply the numerators, you multiply the denominators, I get 10 over 90, and then you reduce after and you get 1 over 9. Technically correct, but this, knowing this, makes doing questions like this and these more complicated ones so much easier. When you reduce before you multiply. Okay, because that's really what you're doing. When you do the cross-out thing here, you're reducing. So that if you reduce everything, your answer, you don't have to worry about reducing your answer. Now notice this one, I didn't ask you to do any non-permissible values because there's no variables. Okay, what would be the non-permissible values for B?
4 and 8.
No, non-permissible values first.
Oh, wait, what can, okay, 0.
So we can just say NPV equals 0, or we can say X can't be 0 and Y can't be 0. Okay, that's fine. Now we start reducing. And notice we can reduce numbers, like Sonia did here, but we can also reduce variables. So the 4 and the 8 reduce to what? 1 and 2. Now let's look, now there's a 3 on the bottom too over here, but there's nothing to reduce with up top. So I'm done with the numbers. How many X's are on top? 2 of them, right? How many X's total are on the bottom? 2, right? So don't all of these cancel out to 1? Because if I've got X squared up top, and I've got an X times X on the bottom, which is also X squared, anything divide itself is 1. So those things all become 1. But what about the Y's? How many Y's can I take out? 1. So if I divide 1 Y here, I'm left with 1. If I divide 1 Y here, I'm left with Y. So what are we left with? 1 times 1 times Y. And then 1 times 1 times 2 times 1. 2. And that's simplified. Yeah. Sorry, 3. 3 times 2. 3 times 1 times 1 times 2 times 1. Thank you. Y over 6. Good catch. Now, if we've got bigger expressions, just like we did with reducing in the last lesson, we have to factor everything we can and then see what we can reduce. So this is why you got to know your factor. Notice I'm not stating my NPVs yet because they have to be in factored form. All right, and there's different types of factoring. There's 3 types of factoring going on in this question. How am I going to factor this one? X squared trinomial, which means it's going to go like this. Over, what kind of factor is that? Perfect square, difference of squares. You guys can call it whatever you like, as long as you know how to do it. What do I get? Okay, so we factored the first expression. Second expression, we've got another x squared trinomial up top. X minus 3, x minus 1. What do we got on the bottom? Nope. It's 4x is not a perfect square. GCF. I can take out an x and be left with x minus 4. Now, don't start canceling yet, because we've got to state the NPVs. Because if we do the NPVs at the end, we're going to miss some. So look at all the denominators. Just look at each factor. What can't x be? So there's 4 NPVs, -3, +3, 0, and 4. Now go to town. Any identical numerator with any identical denominator. So the x plus 3's right there can go. What else could go? X minus 3 there, x minus 3 up top. X minus 4 there, x minus 4 there. So what am I left with? Perfect. Factor everything that you can first. Go ahead. And if you want to keep going further, just remember, before you start canceling things, state your NPVs after you factor. Top left. A plus 5, a minus 5. Bottom left. It's another difference of squares, a plus 1, a minus 1. Top right. GCF, yeah. And last one. Go factoring. Now remember what I said. Lindsay, you've got to treat it like it's that. Okay? Yep. Let's do the NPVs first. Remember, you want to do the NPVs now. So, and just look at the denominators. The numerators, they can be 0, but the denominators can never be. So what are they? -1, 1, 5. Now go to town. Hopefully you can see you can take out a minus 1s.
can not make 5 minus a h negative 1 h.
Don't these cancel to -1? So it doesn't matter where you put the -1. You could put it up top here, you could put it on the bottom. It's still going to be the same. Looks like that's as far as I can go. So I've got -1, or sorry, I've got a plus 5 in parentheses times -1 times a, which is the same as -1 times a, which is -a, times a plus 5. And on the bottom, I've got a plus 1. Now, something you do not, and I suggest you don't multiply it through. You don't have to. This is perfectly acceptable. I've seen students do that. I've seen students do a question where the final answer will look something like this: x plus 1 over x minus 2 times x plus 7 times x minus 5. And then they'll try and multiply all these through. Do you know how many multiplications that is? That's like 6 multiplications. That's tons of work. Don't do it. Leave it in factored form. Okay. We've done multiplication. What's division? One extra step, right? What do we do with division questions? We change them to multiplication. And then it's like the previous page. So if we just do a review, what does this become as a multiplication? 5 over 3 times 6 over 1, and then do your reducing. So 3 and 6 reduce down to 1 and 2. I'm left with 5 times 2 over 1 times 1, which works out to the whole number 10. No NPVs there because there's no variables. Okay, this one was very similar to the previous one with multiplication, except it's a division. So what we're going to do, state the NPVs right now. What is it right now? What can't y be? 0. Okay. Now do your flip. You notice you got a new denominator after you flipped. You have to do NPVs on that too. Did it change or is it still 0? Still 0, so we're good. But that's the other thing with division, with NPVs. You've got to do them twice. Once when it's in division form, once when it's in multiplication form, because some new NPVs might arrive. And now we cancel. Y squared and y, I can take the divided y out of each one. X squared and x, I can divide an x out of each one. And I'm left with 3 times x times 1, which is 3x. On the bottom, y times 1, which is y. Now we go to the bigger ones. When we see big ones like this, when we see we can factor them, that's the very first step we did. So, what does this factor to? Let's do x minus 2. Bottom, GCF, so x times x minus 4. Remember, we're still in division.
X minus 2
Minus 2x plus 3.
X one, 4,
X plus, sorry,
minus 1 plus 1.
X minus 4, X plus 1. Don't flip yet. Do your NPVs. When it's in division form, what are the NPVs? 0, 4, 4, we don't have to write it twice, -5. Now flip the second fraction. First one doesn't move, doesn't change. So this now goes up top. And the top goes on the bottom. And I gotta do NPVs again. Did any new ones appear? 2 and -3, you can just add them to this list up here. So you can just, you don't have to write them all over again. You can just add them to the list that you started when it was in division. So we got 5 NPVs in this one. And now we are ready to cancel, to reduce. So we got X minus 4s, X minus 2s. Looks like that's it. So remember, leave it in this form. Don't multiply through. So we've got X plus 2 times X plus 5 on top, and X times X plus 3 on the bottom. Okay, I want you to try the last one. Give the last one a shot. Okay, so I'm going to start. So first thing we're going to do is factor everything. So it's p minus 7 times p plus 1 squared trinomial. That's splitting squares, p plus 7, p minus 7. Divide another ax squared trinomial, which is p plus 7, p plus 1. On the bottom, I got a GCF 2 times p plus 7. So now I start my NPV list, which so far is -7, +7, and 0. Flip, add to my NPVs if I need to, and then reduce to get the final answer. So p minus 7 times p plus 1, p plus 7 times p minus 7, and now I change it to multiplication and flip. Looks like I'm going to get one new NPV, and that's -1. And it looks like I've got a lot I can cancel. The p plus 1s. I got 2 p plus 7s to choose from below. I got p minus 7. So it looks like I'm left with p over p plus 7. You don't necessarily need the parentheses around p plus 7. Still correct. Okay. Yes.
I have a question because I didn't cancel out the negative and the positive p and 7. So I got
Right, you can't, those don't cancel out to -1. It's p minus 7 and 7 minus p.
Oh,
Yes, the terms have to be reversed, and both have to be subtraction. Good question.